So this word bounded plays a very, very important role in this part of our class because there are some deep theorems related to this property, bounded. So we should define it. A sequence is bounded if and only if what? For every natural number n, the nth term is less than some fixed number k. If that's the case, then we call k an upper bound for the sequence. And of course, if it has an upper bound, we say that the sequence is bounded. Here's a silly little example. The previous example, this is clearly bounded. Here, I'll go through some of the thinking that goes into it, saying that it's bounded. Of course, 3 plus 5 over n, you would expect as the n's get larger. Keep in mind that your n's are going from 1, your n's are natural numbers, so they're 1, 2, 3, 4. Sometimes it could be 0 as well. Sometimes people start the sequences at 0. Let that slide for a little bit. For now, let's consider that it's just natural numbers. As your n's move from 1, this is equal to 8. For 2, this is 2 plus 2.5, 3 plus 2.5, etc., etc. I'm computing my sequences here. For n is equal to 1, this is equal to 8. For n is equal to 2, this would be 3 plus 5 over 2, which would be 3 plus 2.5. So it would be somewhere around there. 3 plus 2.5. For n is equal to 3, what would it be? For n is equal to 3, it would be somewhere around there. It would be 3 plus 5 over 3, which is less than 5. It would be right around here, and so on and so forth. For 4, you see these sequences, they almost behave like functions, of course, but they're just dots. There's nothing in between here where a function might be a continuous line here. The sequences are slightly different in that they only touch dots here, as the domain is only natural numbers and sometimes whole numbers, meaning that sometimes 0 is included, the number with a whole. Alright, now so bounded, we were talking about bounded. You see that the highest that this function got was 8. So I could pick another color here, like red. Don't be mad, Bella. It's alright. We're gonna bound it now, relax. She didn't like this example. Alright, so Diego, tell Bella to be quiet, Diego. So oh my goodness. So anyways, you could pick a number like 9. Obviously all these little dots lie below 9. So you could say this is less than 9 for every possible n that you could choose. That's a natural number. My sequence here, a n is less than 9. So then we call that guy right there is called an upper bound. An upper bound, and we say that if it has an upper bound, we say that the sequence is bounded. In this case, it's bounded above. You could also make an argument that it's bounded below by probably 3 or something like that. It's always above 3. But anyways, sometimes you can use common sense, and sometimes you want to, where common sense fails you, you want to use rigorous ideas. So perhaps I should do the same example and make it a little bit more rigorous. That would go something like this, maybe. We'll start off with a new page. Let's just start off clean, yeah? So we go with, say, I want to prove that 3 plus 5 over n is less than, I don't know, is bounded by 9 for all natural numbers n. Okay? So and I want to do this more carefully than before, just so that you see carefulness being done. You could go like this: n is always greater than or equal to 1. That's by definition because it's a natural number. Okay? So therefore, 1 over n is less than or equal to 1. That's what happens when you flip them. You got positive numbers. This one's bigger than that one. That means that if you flip it, here I'll flip it, then the inequality changes. Then I know that 5 is less than or equal to 1, so I can multiply these two together, I multiply, and these two together I multiply. So I get that 5 over n is less than or equal to 1, obviously. And of course 3 is less than or equal to 8. Just some random stuff here because I'm trying to get a 9, so I'm thinking that if I add these two together, I know 3 is less than 8, that's obvious. So if I add these 3 plus 5 over n, that's less than or equal to 9. And so often you may try to play some ingenious game here with your 3.5 pound brain to bound inequalities in a more rigorous way. This should be more persuasive than the previous graph we talked about. And I say that because, why do I say that? Because sometimes it's not that easy to show things are bounded. Sometimes you have to be extremely careful. This one is easy to show that it's bounded because if you plug in, let's do the list on this one. The list on this one would go something like this. For n is equal to 1, you get sine of pi, which is 0. N is equal to 2, you get 0. N is equal to 3, you get 0. Haha, this one is so bounded, it's 0. But sometimes it's not that easy. Sometimes it gets a little bit more interesting. For example, on this one, this is super famous. Timeless stuff here from Euler. To show that this one is bounded, it's a lot more interesting. If you want a nice weekend project here, forget painting the deck. That's for the birds, man. If you want a good weekend project, try to prove that this is bounded. If you just try to look at it, it goes like this. It says the first item for n is equal to 1, you have 1 plus 1 over 1 raised to the 1, which is equal to 2. For n is equal to 2, you have 1 plus 1 over 2 raised to the 2. For n is equal to 3, 1 plus 1 over 3 raised to the third. And it's not exactly clear that these things will be bounded because this one gives you 2, this one gives you 1 plus a half, that's 3 halves, squared, that gives you 9 over 4, which is slightly bigger than 2. This one gives you 4 over 3 squared, which is equal to 16 over 9, which is slightly bigger than that one. And so they keep getting bigger and bigger and bigger. It's not exactly clear that they will ever be stopped or bounded by anybody. Maybe it goes all the way to infinity. So sometimes proving that something is bounded is a lot more difficult, and so you want to be able to do things rigorously, step by step, as we've done for this example, but on a much deeper level for this one here. Try this one on your own for fun. Try to show that this is bounded, and you'll have lots of fun, I promise. Alright, so that's the story on bounded. That's what it means, and it's an important property because it gives us some other things that we will talk about in the next couple of videos. Alright, we'll see you guys. That's bounded. Cut.